So today we are going to be talking about angles of rotation. There's actually quite a bit to go through. I did put this on Google Classroom. You're welcome to look through and fill out with me as we go through it. But let's start first, talk about angles that are in standard form, okay? So when an angle is in standard form, it basically is going to start on the positive x-axis. This first side, the part of the angle that is on the positive x-axis, we actually call it the initial side of the angle, okay? And then as the angle opens up, the other ray or the other side of the angle we call the terminal side, okay? All of the angles that we do are going to be in this form, in standard form, so all of the initial sides are all going to be starting at the positive x-axis. If you go counterclockwise, okay, so the direction that this angle right now is pointing, then you're going to get a positive angle measure, okay? If you end up going the other way, so if you go clockwise this way, then you get a negative angle measure. And so it's very important that you know which direction it is. And then hopefully you know what one full revolution is. So the 0 degree angle is also the same thing as 360 degrees, okay? So now what we're going to do is we're just going to sketch a couple of angles. I just kind of want to know what quadrant these angles are in. Let's start with 75 degrees, knowing that this is where we start at 0. I know that 75 is going to be somewhere in this first quadrant. The only thing that I want you to kind of keep in mind are your 45 degree lines. Since 75 is past 45, I know it's going to be in here somewhere. So between 45 and 90, okay? Negative 160, so here I'm starting at 0 again. This time it's negative, so I have to go clockwise. And when I get to this line, I'm at negative 90. And when I keep going a little bit, negative 160 is going to be really close to negative 180, or this line over here, okay? 430 degrees, remember one full revolution is 360, and so 430 is going to be all the way around 360 plus an extra 70 degrees, right? And so 70 degrees is right here, but if we go all the way around, we end up with 430 degrees, okay? I know some of you were probably wondering a couple of days ago, what in the world is a radian, Miss Hunsaker? I know that some of you know what it is. I know that some of you don't. I really wish that I could show you this, but, you know, we have to make do with what we got. But basically a radian, if you take the radius of a circle, if you measured it with like a string, okay, and you took that little piece of string and you moved it over starting at 0 degrees and you laid that radius out on the edge of your circle, on the circumference, that's what a radian is. So 1 radian is the same length as the radius, just on the outside edge of your circle, okay? So keeping in mind circumference being 2 pi r, if we went all the way around, okay, 360, I'm going to end up getting 2 pi. Okay, remember the circumference is 2 pi times your radius, right? If I go 180 degrees, if I only go halfway around, 180 degrees is going to be 1 pi. Okay, these are two really important things to know and to kind of keep in mind. Okay, so again, halfway around the circle is 1 pi, all the way around the circle is 2 pi. Sometimes you're going to have to convert between degrees and radians, okay? And when you do that, when you go to convert, there's actually some really easy conversions that you're going to do. You're either going to multiply by pi over 180 or you're going to multiply by 180 over pi. Because for every pi radians that you go, that's 180 degrees, okay? So this is basically multiplying by 1. And remember, when you multiply by 1, you don't change the value. So we're going to go take 30 degrees. So I have a degree and I want to turn it into a radian. So I'm going to take my degree measure and multiply it by pi over 180. So that's what I'm going to do for all 3 of these problems right here. Okay, so let's go do that. Let's go take 30 degrees and multiply by pi over 180. Okay, I do a little bit of math, a little bit of algebra, a little bit of reducing, 3 pi over 18 would be the same as 1 pi over 6. Okay? 150 degrees, I'm going to do the same thing, multiply by pi over 180, do a little bit of math, a little bit of algebra. I'm going to go get rid of those zeros. So 15 over 18, that's going to reduce to 5 pi over 6. Uh-oh, negative 220. So when I multiply by pi over 180, okay, let's get rid of those zeros. I can divide by 2. And so 2 is going to go into negative 22, negative 11 times, and into 18 9 times. And so that becomes negative 11 pi over 9. Okay? All right, when I go from radians and I want to find out what degree that is, I'm going to be multiplying. I'm going to take my radian measure and I'm going to multiply it by 180 over pi. And so that's what we're going to do for all of these. Okay, we're going to multiply by 180 over pi. Now, one of the things that I always remember is that you want your pi's to cancel out, because I can never seem to remember which way that you go. And so sometimes it helps, right? If you know that your radian measures are going to have a pi in it, you want the pi in the numerator. If you know that you want to cancel the pi's, you know you need the pi in the denominator, okay? So that's exactly what I'm going to do. I'm just going to go and cancel some things out. I'm going to get my handy-dandy calculator ready. And I'm going to go do 180 divided by 3 because my brain doesn't feel like working at the moment. But I get 60, and then 60 times 4 is 240. So 4 pi over 3 is the same thing as 240 degrees. Okay, let's go do the next one. So negative 5 pi over 36. Again, I'm going to multiply by 180 over pi. I'm going to cancel those pi's out, and I'm going to keep my fingers crossed that 180 divided by 36 is a nice number. Oh, shoo, it is. So I get a 5, and so negative 5 pi over 36 is the same thing as negative 25 degrees. Okay, let's go do the last one. If I multiply by 180 over pi, cancel some things out. 180 divided by 4 is going to be 45 degrees. Let's just go verify that on my calculator, see? And then if I multiply that by that 7 that I still have up there, I end up with 315 degrees. So 7 pi over 4 is the same thing as 315. All right, so the next thing we're going to talk about are what are called coterminal angles. I don't know if you remember, I mentioned something about it on the other page when we were talking about that 430 degree angle, right? And I said there was 70 left over. And so this, 70 degrees and 430, those are called coterminal angles, okay? So they share the same terminal side, okay? So that's what we're going to be doing. So the first thing that we're going to do, we need to actually find 2 coterminal angles for each. So when you have a degree, the easiest thing that you can do with 65 degrees is just add 360. Just go around the circle, okay? And so you get 425 degrees. Now it does say that we want 1 positive and 1 negative angle. So now I want to go and I want to subtract 360. So I just want to take my 65 degree angle and go the other way, okay, and see what I end up getting. And you should end up getting negative 295 degrees, okay. Let's do the same thing with 540. So again, I'm going to add 360, and then I'm going to subtract 360. So this will give me another positive coterminal angle as well as a negative coterminal angle, okay. And so when I do that, I get 900. And when I do that, I get 180. Oh, wait a minute. It's not negative. What am I going to do? Got any ideas? Oh, I'm hoping that you just said to go subtract another 360 degrees. And so, yeah, when you do 180 and you subtract another 360, you end up with a negative 180 degrees. Okay? All right, so let's go do it when it's in pi or in radians. So what do you do when it's in radians? So what was the same thing as 360 again? It was 2 pi. So we're going to take 13 pi over 18 and we're going to add 2 pi because that's 360. That's a full revolution. So, oh snap, we got to keep things in fraction form, right? And so this is going to be 36 pi over 18. And so when I add those together, I end up getting 49 pi over 18. So there's my positive coterminal angle. And then we're going to take 13 pi over 18 and we're going to subtract 2 pi, okay, or subtract 36 pi over 18. And that's going to give us a negative 23 pi over 18, okay? Let's do it again. So 14 pi over 9, I'm going to add 2 pi, and then we're going to subtract 2 pi, okay? This time our denominator is a 9, so I'm going to change this to an 18 pi over 9. 14 plus 18 is going to give me 32 pi's over 9. And when I change this one, 14 minus 18 is going to give me a negative 4 pi over 9, okay? All right, let's talk about reference angles. So reference angles are going to be really huge, especially when we get into the unit circle. And so one of the things you do with a reference angle is that you find out what your angle is, but then the reference angle is going to be the opening between the terminal side and the x-axis, wherever it happens to be, okay? So 225 degrees, if I start over here at 0 and I go around, I end up getting it right here. Okay, so this is 225 degrees. My reference angle is going to be this opening between the x-axis and my terminal side. And you always talk about it in the terms of the positive acute angle, okay? And so this is a 45-degree opening. Negative 310 degrees is going to go, starting at 0, it's going to go clockwise around, and so it comes over here. And so negative 310 degrees is over here. And the opening, the reference angle, remember it's 360 all the way around. So this reference angle is 50 degrees. And again, we talk about it in terms of the positive because it's just a reference, okay? We're kind of like thinking it in terms of distance, okay? 2 pi over 3, we may not quite fully understand what radians are yet, so I'm going to convert this into degrees, okay? And I'm going to go change this, and so 2 pi over 3 is the same thing as 120 degrees, and so I know that 120 degrees, if I start at 0, is going to be over here, right? This is 120 degrees, and so this opening inside here, this reference angle, is 60 degrees. Okay, the other thing that you can do is you can take pi and you can subtract 2 pi over 3 to get this reference angle. So 1 pi is the same thing as 3 pi over 3. And so 3 pi over 3 minus 2 pi over 3 would give you 1 pi over 3. Okay, so that reference angle is also pi over 3. All right, so the last thing that we're going to talk about are these trig functions. And so I went ahead and filled a couple of things out, just doing Pythagorean theorem based on the picture that is over here. You know that you can find the radius by taking x squared plus y squared, adding it together, and then square rooting it. And then using our trig functions from the other day, sine, remember, is going to be opposite over hypotenuse. And so if this is our reference angle, the opposite is y, the radius or hypotenuse is r. And so I just flipped these guys, or I just went ahead and did them. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then flipped them over. So we're actually going to go do one now. And so if we had a point 5, negative 2, that point is going to be right here. Okay, this is positive 5, negative 2. And what I want to do is find all of those trig functions. So if I make a little table, I know that my x number is 5 and my y number is negative 2. I can do Pythagorean theorem, right? I can do 5 squared, which is 25. Negative 2 squared is going to be 4, and so my radius is going to be the square root of 29. And I'm just going to do y over r, x over r, y over x, and so on and so forth, okay? Okay, so then you can see just the last little bit that I did. If we know that the radius is the square root of 29, we can just follow these things up here, right? Y over r, so negative 2 over root 29, and rationalize our denominator, okay? Hopefully this makes a little bit of sense. Please make sure that you ask me for questions if you have any, but you're going to be trying some problems on your own, okay? All right, happy trig.